All right, students, so we're in Chapter 4, Lesson 2 today. This one's called Area of Triangles. So we're shifting from parallelograms into triangles today. Same thing though, we're trying to find the area of those. So our learning target is I can find the area of a triangle. So we'll get that in. So first thing to do is talk a little bit about what triangles look like. We all know that triangles have 3 straight closed sides. It's important to label their measurements. So if I have a triangle like so, the height of the triangle is from the top point all the way down to the bottom point. I like to label it with a dotted line, so I'm going to label that with an H, or height. And the other measurement we're going to need to find the area is the base. This bottom is called our base, so we're going to put a B for base. Same as parallelograms, the H is going to stand for height on our triangle, and the B is going to stand for the base of our triangle. Remember, the height is not going to be one of these slanted sides. The height is going to be from the top point to the bottom point of our triangle. So how tall is this going to give us? Something to also note about triangles that helps us with the formula for how to find the area is that a triangle is really just added together to make a rectangle. So for example, if I drew a triangle that looks like that, and then I drew another triangle that looks like this, together, if I put these two triangles together, this creates a rectangle. So a triangle is really half of a rectangle. So that's something to note on the side. A triangle is 1/2 of a rectangle. My drawing isn't the best up here. However, you can kind of see how those two pieces together make one whole rectangle. This 1/2 is going to actually be utilized in our formula for how to find the area of a triangle. So if I'm going to find the area of a rectangle, I would just do length times width. On a triangle, I'm going to do base times height, and then I'm just going to cut it in half or divide it by 2. That bar means division. Another way you could write it is base times height times 1/2. So taking 1/2 of the base times the height. So that's another way to write it. Remember, we don't need those multiplication symbols in between these letters and numbers, but if you'd like to write them, you can. So just multiplying the base and the height and dividing it by 2 or timesing it by 1/2. That's what we're going to be doing today. Our book needs to be open to page 160, so pause the video so you can see where the examples are that I'm going to be pulling from. It's important that you're looking to see where I'm getting these things. So the top of 160, our key idea there is the same thing we just discussed. The area A of a triangle is 1/2 the product of its base, B, and its height, H. So we're going to get into our examples. Finding the area of a triangle. Example 1, find the area of this triangle. So we're going to actually draw it similar to our parallelogram drawings from yesterday. This yellow triangle looks like this. We have line going down straight as you can. My lines aren't very straight. There's my triangle. They tell us that this side is 8 inches and that this side is 5 inches. And they also give us a little box here. If you remember from elementary school, that little box just tells us that this angle here, this corner, is a 90-degree angle. So it's straight out and straight up. That's a 90-degree box. Or a right angle is another way to say that. So if I want to find the area of this triangle, I'm going to take the base, which is the bottom of the triangle here, which is 5. And then I'm going to multiply it by its height. Top point to bottom point is 8. And then I have to divide that by 2. We're going to multiply the top numbers first, and then we'll divide by 2. So 5 times 8 is going to give us 40. Then I have to take that 40 and divide by 2, which gives us 20. So our area equals 20. And the label, again, same as yesterday or parallelogram day, is inches squared. So that entire thing is our label, 20 inches squared for example 1. Okay, so at the bottom of page 160, you're going to see 2 try on your owns. Go ahead and pause the video and try those out. See if you can find the area of those triangles. Okay, number 1 is 22 feet squared, and number 2 is 110 meters squared. Now taking a look at page 161 and example 2. This one says finding the area of a triangle again. Find the area of this triangle. What I'm noticing here, the difference between this example and the last example. The first example, we had the lines labeled very clearly. On this new example, the height is actually measured on the outside of the triangle. So we have a different looking triangle here. So let's draw it first. Looks something like that. And they tell us that this measurement right here, this little red line that they have in the book, is a 90-degree corner, but it's not part of our triangle. This over here is our triangle. So from this top piece to this bottom piece, they're telling us that is 9 meters. And the reason that they're labeling on the outside of the triangle here is because there's no really other spot on the inside of the triangle to label this triangle's height from the top point to the bottom point of the triangle. So they're just doing that for us on the outside of the triangle. Then they tell us that this bottom line right here is 12 meters. So we still have everything we need to solve for the area. So on this one, area is going to be base times height divided by 2. Base here is 12. The height is 9. And then we have to divide by 2. So if we do 12 times 9 on the top, divided by 2, we end up with area equals 54 meters squared. If you wanted to break that down and do it one step at a time, 12 times 9 on the top, divide it by 2 on the bottom. You could simplify if you wanted to, the 12 and the 2 before you did this division, or you can just do 12 times 9 on the side and then cut it in half. And that brings us to the end of example 2. We only have one more example. Example 3 gives us that real life application. How would we take area of a triangle and put it into our real world? This one talks about butterflies. So we're still on page 161. Example 3. The base and height of the red butterfly wing are 2 times greater than the base and height of the blue butterfly wing. How many times greater is the area of the red wing than the area of the blue wing? So now, a lot of students and a lot of people actually would just automatically say, well, if the base and the height are 2 times bigger, then the area was probably 2 times bigger. But we're going to show and prove today that that's not the case. So it's important for us to go all the way through the work here. So on the left, you'll see the area of the red butterfly. You've got some things labeled there next to the flower. And then you see the area of the blue butterfly, and you've got some labels there next to that flower. So we're just going to go ahead and draw the triangle that represents the butterfly's wings here. So the first triangle we're going to draw is the blue butterfly's wing, and it's kind of in this direction if you take a look at that wing. The height here, whoa, my lines are very not straight here. My height, I'm going to put a little arrow there, of this triangle that's kind of tilted, they give us is 1 centimeter. And then they tell us that from this side all the way to this side of this wing is 2 centimeters. And technically this is a butterfly, but really we're pulling the triangles out of it is what we're wanting. And then the second butterfly wing kind of is tilted in this direction, and it's quite a bit bigger. And so they tell us there, all they do here is give us a line and give us an H and then a B for the bottom here, the base, all the way across. So in the directions, it tells us that the big dimensions are 2 times more. So we're going to write that down. Big dimensions are 2 times greater. So that's going to help us determine what these dimensions are here. So 2 with 2 times greater, that turns this B into a 4 centimeters. And then 1 times 2 is going to turn this into a 2 centimeter for its height. So now we've got both dimensions here. Now that we have both dimensions, we can go ahead and find the area of both of the butterfly wings. So the area of the little guy, we have a base of 2 and a height of 1, so we would go 2 times 1 divided by 2. 2 times 1 is 2. 2 divided by 2 would give me 1 centimeter squared. The area of the larger butterfly wing, our base is 4, so we have 4 times 2. 4 times 2, base times height, divided by 2. So the area of the large butterfly wing, 4 times 2 is 8, divided by 2 would be 4 centimeters squared. So if you take a look at our answers here, we have 1 centimeter squared versus 4 centimeters squared. Our dimensions are 2 times greater. The little dimensions here, the bases and the heights. However, our areas are not 2 times greater. From 1 to 4, it's 4 times greater. So if we look back at the question here, it says how many times greater is the area of the red wing than the area of the blue wing? Our answer we would put is 4 times greater. That would be our final answer here. Because the larger area is 4 and the smaller area is 1, that's a difference of multiplication by 4. The bottom of that page, you'll see 2 on your owns. Go ahead and try those out and pause the video. Okay, number 3, finding the area of that triangle. You should have 60 centimeters squared. And number 4, it's asking how many times greater. That's going to be 9 times greater, that what if question. That brings us to the end of the second lesson of chapter 4.